Hello students, in this section we are going to study how to use differentiation to find if the function is increasing, decreasing or none. Let's consider the first example, y is equal to x plus 3. Now observe that this is a linear equation, hence the graph of this function will be a straight line. Let's take the values of x and find the values of y equal to f of x. So when we take x is equal to 0, our y value is 3, x is equal to 1, y is equal to 4, x is equal to 2, y is equal to 5 and so on. So we get a graph which passes through 0, 3. Now observe that as you increase the value of x, the value of y is also increasing. So we had 1 is greater than 0. But what was f of 1? F of 1 was equal to 4 and f of 0 was equal to 3. So f of 1 is also greater than f of 0. In other words, as x is increasing, y is also increasing. Such a function is called as the increasing function. To sum it up, if x1 and x2 belong to some interval I such that x2 is greater than x1, then f of x2 is greater than f of x1. Such functions are called as increasing functions. Now let's consider the second example, y is equal to minus x plus 3. Let's take the values of x and y. So when we take x is equal to 0, y is equal to 3, x is 1, y is 2. When x is 2, y is 1 and so on. Now observe that as you increase the value of x, the value of y is decreasing. So we have 1 is greater than 0, but f of 1, see f of 1 is equal to 2 and f of 0 is equal to 3. So 3 is greater than 2, so we have f of 1 less than f of 0. Such a function is called as the decreasing function. So to sum it up, if x1 and x2 belong to some interval I such that x2 is greater than x1, then f of x2 is less than f of x1. Example 3. Let's consider the graph of y is equal to sine x. Now observe that in this graph, in the interval 0 to pi by 2, the function sine is increasing. So y is increasing. In the interval pi by 2 to 3 pi by 2, the function y is decreasing. So now, if I ask you to tell me if the function sine x is increasing or decreasing, you will ask me which interval should I consider. Is that right? Suppose I ask you from 0 to 2 pi. From 0 to 2 pi, observe from the graph that the function sine is increasing, then again decreasing, then again increasing. Okay? So, such graphs where you cannot tell for certain whether it is increasing or decreasing are called as neither increasing nor decreasing. Now, in all the three examples that we took, we knew what the graph of the function would look like. And looking at the graph, it was very easy for us to tell whether the function was increasing or decreasing or neither increasing nor decreasing. Now, what if I give you an equation of the function y is equal to x minus 1 the whole cube, x squared into x plus 2. Now it becomes difficult because we don't know what the graph of this function looks like. That's why let's go back to the previous three examples and make some new observations so that we make this problem look little simple. Observe now the example number 1. This equation y is equal to x plus 3 is in the slope-intercept form y is equal to mx plus c. Comparing the given equation with the slope-intercept form, we have the slope m is equal to plus 1. Similarly, let's consider this equation 2, the example number 2. Comparing this with y is equal to mx plus c, we see that the slope m is equal to minus 1. Now we have already studied that if the slope is positive, then the angle of inclination is acute angle. And if the slope is negative, then the angle of inclination is an obtuse angle. So now observe that if the slope is positive, we have got the function to be an increasing function. And if the slope was negative, we got the function to be a decreasing function. So the new observations that we made where slope was positive, angle of inclination was acute, and we got an increasing function. Here slope was negative, angle of inclination was obtuse, and the graph or the function is a decreasing function. Now let's consider the graph of sin x one more time. Now observe this graph carefully. Let's consider the interval from 0 to pi by 2. Let's draw graphs to the tangents to this curve. Now we can draw any number of tangents. We see that the angle of inclination is always acute. Angle of inclination is acute, so the slope is always positive. And we observe that from 0 to pi by 2, our function was increasing. So we also observed that slope m is positive because the angle of inclination theta is acute. Let's observe the next interval pi by 2 to 3 pi by 2. I can draw any number of tangents to this curve. I will observe that I'll get the angle of inclination theta to be obtuse angle, and hence my slope will be negative. So now what do we mean by the term slope? If you remember, in our first year we have discussed and we have written the formula of slope as y2 minus y1 divided by x2 minus x1. In other words, numerator was change in y-axis and denominator gave us the change in x-axis. In other words, this is nothing but dy by dx. So if the function y is equal to f of x is given to us, then dy by dx is equal to f dash of x gives us the slope of the tangent and hence the slope of the curve. So to sum up the observations that we have made, if slope was positive, the function y is equal to f of x was an increasing function. In other words, if f dash of x is greater than 0, we got y is a increasing function. If slope was negative, then y is equal to f of x was a decreasing function. So, in other words, if f dash of x is less than 0, then the function is a decreasing function. Now, let us consider the following graphs. In the graph number 1, we observe that from here to here, the function is increasing. In other words, f dash of x is greater than 0. Now what happens in this interval? You see that the line is parallel to the x-axis. So the slope or f dash of x is equal to 0. That means the function attains the constant value in this interval. Now after this, from here to here, again it is a increasing function. So f dash of x is greater than 0. To put it together, we have f dash of x is greater than or equal to 0 for this function. So first graph is an example for increasing function. Now let's consider the second graph. Observe that throughout the domain, the function is increasing. Not only that, it is strictly increasing. So, throughout this curve, if we find out the slope, we will get f dash of x strictly greater than 0. So, the graph 2 is an example for strictly increasing function. Now let's observe the graph 3. We observe that from here to this interval, we have f dash of x is less than 0. This is decreasing, is that right? Here in between, again, it is parallel to the x-axis, so f dash of x is equal to 0. And after this, we get f dash of x is less than 0 again. So to put it together, we have f dash of x is less than or equal to 0. So this is an example for decreasing function. Now observe the graph number 4. Observe that throughout the domain, the function is strictly decreasing or the slope is strictly less than 0. So we get f dash of x strictly less than 0, and this is an example for strictly decreasing function. Now consider the example y is equal to sin x again. Now here we see that this function is neither increasing nor decreasing. So this is an example for neither increasing nor decreasing. To sum up all the observations that we have made, we have the following 4 points. The exercise 6.2 has 2 types of problems. Problem type 1. State whether the following functions are increasing or strictly increasing, decreasing or strictly decreasing, or neither increasing nor decreasing in the given domain. And problems of type 2, we have to find the intervals in which the function is increasing or strictly increasing, decreasing or strictly decreasing, or neither increasing nor decreasing. So now let's solve the question from type 1. So now let's solve the questions of type 1. We have the first question. Show that the function f of x is equal to 3x plus 17 is strictly increasing in R. R is the set of real numbers. So let's take x1 and x2 in the interval, that is in the set of real numbers, such that x2 is greater than x1. So 3 times x2, I'm multiplying 3 on both the sides, we get 3 times x2 is greater than 3 times x1. Now let's add 17 on both the sides. So 3x2 plus 17 is greater than 3x1 plus 17. So we got f of x2 is greater than f of x1. So we had taken x2 strictly greater than x1 and we arrived at the conclusion where f of x2 was strictly greater than f of x1. Therefore, the function is strictly increasing in real numbers. There's another way to solve this. You can simply find the slope of this function. Either you can compare it with y is equal to mx plus c and find the slope, or you also know that f dash gives you the slope. So f dash of x is nothing but 3 into 1 plus 0, which is equal to 3. Now observe that f dash of x is 3, which is strictly greater than 0. So from the observations that we have made, we can say that the slope is positive and hence the function is strictly increasing in R. Second question. Show that the function f of x is equal to cos x is strictly increasing in pi by 2 to 3 pi by 2, strictly decreasing in open interval pi by 2 to pi, and neither increasing nor decreasing in the interval pi by 2 to 3 pi by 2. Now, let's first find what is f dash of x. So, f dash of x is differentiation of cos x, which is minus sin x. Now, let's consider the sub-question 1. In the interval pi to 3 pi by 2. Now, pi to 3 pi by 2 is nothing but the third quadrant. And we know that in third quadrant, sine is negative. So, sin x is less than 0, negative in the third quadrant. So, what happens to minus sin x? Minus sin x will be greater than 0. So, minus sin x was nothing but f dash of x. So, f dash of x is strictly greater than 0. So, we can say that f is strictly increasing in the interval pi to 3 pi by 2. So, that was the solution for the sub-question A. Now, let's see the sub-question B. We have the interval pi by 2 to pi. In the interval pi by 2 to pi, we observe that sine is positive. So, we have sin x greater than 0 in the second quadrant. But minus sin x will be less than 0. And in other words, f dash of x is strictly less than 0. This will imply that f is strictly decreasing. So, strictly decreasing in the interval pi by 2 to pi, or in other words, in the second quadrant. Now, let's observe the interval pi by 2 to 3 pi by 2. That is our question, sub-question 3. From the sub-question A and B, we can say that f is neither increasing nor decreasing in the interval pi by 2 to 3 pi by 2. Now let's consider the questions of type 2. Find the intervals in which the given functions are strictly increasing or decreasing. Let's take the first question as f of x is equal to 2x square minus 3x. F dash of x is equal to 4 into x minus 3. Now, we have observed that if the function has to change its nature from increasing to decreasing, then there will be a point on the curve at which the tangent or the slope of the tangent will be equal to 0. And this point will basically divide the interval into 2 or more intervals. So, let's put f dash of x is equal to 0. So, what happens? 4x minus 3 will be equal to 0. So, x will be equal to 3 by 4. So, we have the entire real number line minus infinity to plus infinity, and this point 3 by 4 broke this interval into two intervals. Now let's draw the table. First column will make a note of all the intervals. So we got two intervals, minus infinity to 3 by 4 and 3 by 4 to plus infinity. Now let's check the sign of f dash. We are checking this because if f dash of x is greater than 0, we can write the nature as strictly increasing, and if f dash of x is less than 0, we can write the nature as strictly decreasing. So now let's find out. Now let's take any real number in this first interval. The first interval is minus infinity to 3 by 4. So I can take any number. So I can take 0, I can take minus 1, minus 2, minus 100, minus 1000, any number which is less than 3 by 4. Yeah. So let's take the value 0. So suppose I take a 0. Substitute in f dash of x. So if I substitute it in f dash of x, we get f dash of x is equal to minus 3 when x is equal to 0. This is strictly less than 0. So if it is strictly less than 0, we conclude that f is strictly decreasing. Now let's consider the second interval. Let's take any value in the second interval. I can take 1, 2, 100, 1000, anything. I'll take x is equal to 1. So if I take f is equal to 1, x is equal to 1 and substitute it in f dash of x, we get 4 minus 3, which is 1, which is strictly greater than 0. So f here is strictly increasing. And hence, f is strictly increasing in the interval 3 by 4 to plus infinity and strictly decreasing in the interval minus infinity to 3 by 4. Second question, f of x is equal to 2x cube minus 3x square minus 36x plus 7. First, let's find out the value of f dash of x. So f dash of x will be equal to 6x square minus 6x minus 36 plus 0. So here 6 is a common term. We get x square minus x minus 6. So we can factorize this. We want the product to be 6 minus 6 and the sum to be minus 1. So the numbers are minus 3 and plus 2. So x square minus 3x plus 2x minus 6. So this can be again written as, you see in the first two terms we have x is common. So we get x minus 3 plus 2 into x minus 3. Now in the entire term x minus 3 is common. So x plus 2 will remain. So f dash of x is equal to 6 into x minus 3 into x plus 2. Now let's put f dash of x is equal to 0. So when we put f dash of x is equal to 0, we get 6 into x minus 3 into x plus 2 is equal to 0. So either 6 is equal to 0, which is not possible, or x minus 3 is equal to 0, or x plus 2 is equal to 0. So we get x is equal to plus 3 or x is equal to minus 2. Now let's draw a number line minus infinity to plus infinity and denote these points in the ascending order on the number line. Now these points cut the real number line into three intervals. So we have the first interval minus infinity to minus 2, second interval minus 2 to 3, and we had third interval 3 to plus infinity. In the second column, let's find out the sign of f dash. And in the third column, let's find the nature of f. Now, in the first interval, let's take any number in the first interval. So I can take a minus 2.01, I can take minus 3, minus 4 and so on. I will take minus 3. So let's take minus 3 and substitute in f dash of x. Let's substitute it over here. Now what happens? 6 is however positive. Okay. So x minus 3 is there. So x minus 3. So minus 3 is minus 6, which is negative. We have minus 3 plus 2, again minus 1, which is negative. So if I have to put it together, positive into negative is negative, negative into negative is positive. So we get plus sign. So this is nothing but this implies that f dash of x is greater than 0. So if f dash of x is greater than 0, the nature of f will be strictly increasing. Now let's consider the second interval, minus 2 to 3. Let's take any number in this interval. I'll take 0. So if we take 0, 6 is however positive. 0 minus 3 will give me negative. 0 plus 2 will give me positive. So positive into negative is negative. Negative into positive is negative. This implies that f dash of x is strictly less than 0. So we get the nature of f to be strictly decreasing. Now let's consider the third interval, 3 to infinity. Let's take any number in between. So let me take the value to be 4. So substituting 4 in f dash of x, what do we get? 6 is however positive. 4 minus 3 is positive. 4 plus 2 is again positive. So this will imply that f dash of x is strictly greater than 0, which implies that the function f is strictly increasing. Now let's write the conclusion. The function f is strictly increasing in, we have two intervals, interval 1 and interval 3. So we will write it as minus infinity to minus 2 union 3 to infinity. And strictly decreasing in the second interval, that is minus 2 to 3. This is how we solve the problems of type 1 and type 2. Thank you.